Looks like people have come in and out. So this presentation we're about to give is called Keep Calm and Ship Services because it was the first title we came up with and we didn't bother to change it. My name's Tammer and this is Chris. We both work in the London office. We work for Pivotal. I'm director of product for Pivotal CF Services in London, and Chris is my anchor for the development team. What we're going to talk to you today about is basically everything about all of the services that we're building in Pivotal Cloud Foundry and some of the challenges we face and how we build those services, some of the patterns we've come up with, specifically about tenancy and things like that. We're also going to give some overview of the BOSH and Cloud Foundry architecture. For some of you, this is going to be kind of redundant. And also, we're going to talk about the services API and how that works. We're going to try and move fast because everything's been pushed out a little bit, and we know that you guys are going to want your breaks. I do. All right, so let's get started. I believe you got the first two sections.
Yep.
There we go.
Can everyone hear me? Yeah. Awesome. So what would be helpful first is to maybe go over a quick overview of what the runtime in BOSH looks like with services next to it. So we start off with your infrastructure, and then for us it's vSphere. We put operations manager next to it, which deploys BOSH. The runtime goes on top of BOSH. The bit we care about in runtime for services is Cloud Controller. It's really the only bit we talk to. And then for us, the services go next to it on top of BOSH again. And then our console goes on top. So there we showed that you can deploy it with BOSH, but you can do it in a few ways. The first way to deploy services is actually on the Cloud Foundry runtime itself. This brings a number of benefits. That it keeps everything stateless, which isn't a benefit in and of itself, but because you're in services, you're dealing with state, and you really want one source of truth for that state. You don't want to, if you want to check if a user exists, you don't want to check the users in your list of created users. You should just see if the user is in the service. By getting rid of state, you also have the advantage that you can scale on the Cloud Foundry runtime. This isn't maybe so important for brokers again, because they're not proxying all their traffic to your services, but it's just nice to have. But the real advantage is that you get load balancing and high availability. So you're able to keep the broker up all times without having to manage switching the routes. And another key advantage is that all the credentials will come over back from the broker. And so it's important to have that SSL there. And so if your Cloud Foundry is set up with SSL, then you get it all for free. And also, it's ideal for when you're actually being a literal broker and just talking with the external service. So if your nodes aren't deployed with BOSH, then you don't have to deal with BOSH releases at all.
For example, if you've got a dedicated DBA team that's managing your, say, Oracle cluster, then this is an ideal pattern for deploying the service broker that will hand that Oracle cluster out to the application developers and the runtime.
And so another way to deploy them is with BOSH. This is how we do it at the moment. What the advantage this gives you is if you're already having to deploy your nodes with BOSH, then the broker is probably actually going to be the simplest part of that deployment. So you're not really adding much more complexity by just putting the broker in BOSH as well. If your broker does need to store information on the file system, like PID files or configuration files, then you really only have to use BOSH because all the storage inside Cloud Foundry is going to be ephemeral, and you're going to lose it. It also gives you increased flexibility. When running on BOSH, you have VMs and you start processes. You can really do whatever you want inside there. So BOSH, if you use Ops Manager and use products in there, BOSH releases are a first-class citizen inside there, and it'll be much easier if you use BOSH there. However, in Ops Manager 1.2, there's a new feature called errands, which you could push apps with that instead. But the problem with BOSH is there's a high barrier to entry, so you've got to wait up. And then I'll hand back to Tammer to talk about the services API.
Thank you very much. All right, so let's talk about the services API and how services are provisioned and used inside Cloud Foundry. got these nifty little diagrams. So down here, you can see, again, the operations manager, which is deployed BOSH on top of the infrastructure. We've got a running runtime sitting next to it. Over here, we've deployed a service. It's a completely separate deployment. It's not part of runtime. It's not inside of it. But it does have a service broker. So here, we're kind of illustrating the BOSH deployed service broker pattern. So the service broker is sitting inside that deployment. And it's been registered with the cloud controller. So there's a very few number of actions that can take place between the cloud controller and the service broker. And we're showing up at the top the command that you type to kick off each one. So when you run CF Marketplace effectively is when the cloud controller asks the service broker for its catalog. And the service broker responds with a bunch of metadata describing, OK, here's what I've got to offer. Here are the various plans. I might be offering multiple services, but for now, we just care about the one. And then apologies for the hard-to-read picture, but that's kind of showing that all this information basically gets exposed right back into the console, as well as the return value from CF Marketplace on the command line. So now you know what services are available. You know what plan is available. So you're going to go ahead and create one. So create service foo, right? And you give it the plan name as well. So what that does is kicks off a provision request from Cloud Controller to the service broker. And now you can see this little blue node showed up inside the service nodes. And that represents the service that we've just provisioned. Next, we're going to bind that service to my application. So once you kicked off that command, again, it kicks off a binding request to the service broker, which returns the binding information to Cloud Controller. A little hard to read down there, apologize, but basically it's just some JSON that describes the username and password credentials and exactly where the service is. And then that's handed off to the application. Now, from that point on, and this is a very important fact about the service broker API and why we renamed it from the service gateway. From that point on, the application talks directly to the service. It already knows where the service is. It knows the credentials. So we're not going to get in the way. We're not going to cause any issues with uptime. And it's also why the service broker itself doesn't really have to scale very high. Service broker is only used during the instance creation and the binding aspect. Pretty rare, actually. So here's the overview, again, of those 5 API endpoints. This is one of the simplest APIs I've ever worked on or seen. We don't even support the full range of HTTP verbs. Who all here is familiar with RESTful APIs? Raise your hand if you are not. All right, everybody's good. So we don't even support all the verbs on all these. Most of them just support put and delete, and catalog only supports get. So it's a very simple API. All right, I believe you're going to talk about vocabulary.
Yeah. So it's probably helpful at this point to explain some of the terms that we use when building a service broker. There are 4 main ones. There's a service, which is at the top level logical. This, like a service broker can advertise a number of services. This is probably mapped to the different kinds of technologies that you use. The plan is your chance to vary the service offerings you have. So you could change the capacity or the performance or another attribute about the service. The instance is what the user gets when they type CF create service. This can mean a number of things, which we'll go into in a minute. And then the binding is the relation between an app and a service. So just a tip is to really be explicit about, even your coding and conversation, about which one you mean. Because depending on who's asking, all of these could be a service. You end up calling everything a service. So like service could be a service. From the user's point of view, their instance is their service. And from the app's point of view, the binding is a service. And so,
in fact, the CF CLI even makes it worse by calling it, create service as opposed to create instance. Yeah.
So something we've done in code and also in conversation is make sure that we use the full name each time to make sure there's no doubt. So I mentioned earlier that instance can mean a number of things depending on the service. So it's maybe beneficial to go into detail about what an instance can mean, and this is in the context of MySQL. So you could have an instance be a database created inside an existing MySQL cluster. And then the user gets just that database. This is like applicable for maybe testing and development, but you're very susceptible to noisy neighbors, and if someone else is thrashing the box, then you're gonna feel that. You could give everyone an entire VM when they ask for a service, but at the moment there's a timeout on how long you're allowed to take to provision a service, and depending on your infrastructure, you may hit that timeout. So it's best to have like a pool ready to go. It's the most expensive, but you're not going to have any resource problems here. You could go a step further and have each instance be a cluster of VMs where you have a leader and a follower. This gets a bit harder because you have to handle the failover, but it's possible. You could have a single VM and then start a new MySQL server for each instance. This, again, would be good for maybe development, but as it's all in the same box, you might hit some contention problems. Or what you could do is start using like a cluster scheduler like Mesos and start spreading out the work across a cluster. This allows you to provision quickly and also get the benefits of having high availability. Up until now, we still had all these problems that instances on the same box interfere with each other. But then if you put everything inside containers, you're able, with Warden or Docker, you're able to limit the CPU, memory, disk, and network utilization. So you're really able to stop them interfering with each other. Up until now, all these have been describing a database that's empty, but there's nothing stopping you from, when you create a service, having a database that already has read-only data in there, or write data where you have a sandbox for each developer they can play around. Or sometimes provision could do nothing in the data sense, and it just creates an account in an external service or something like that. And then I'll hand back to Tammer to talk about the services we're building in 2014.
All right, so let's start talking about the focuses that we've had on exactly which services we think are important for 2014. Some of these we've already actually released externally as development level plans. Some of them are still on the roadmap, but we expect to have all of these done by the end of the year. Okay, so the first one is my personal favorite data service, which is Redis. Somebody famously called Redis the AK-47 of databases, which I love. The current instant, all these slides are going to describe what we're currently offering with these, and they're all eventually going to migrate to either dedicated clustered VMs or dedicated clustered containerized processes is the direction we're moving for all these, for the production level of these services. But like I said, this is very nascent, MVP, we're very agile. So right now, Redis is, when you request an instance of the Redis service, the broker spins up your own Redis process, and that's what you get. You get your own. Not yet containerized, but it will be. And check out that animation. The next one is Neo4j, the world's leading graph database. Again, this is very similar, where each instance is a separate Neo4j process. For all of the third-party services where we don't, kind of quote-unquote own the data service itself, unlike Redis, where the person who, the maintainer of Redis is on our payroll. For all the rest of these services, we've got specific go-to-market partners that we're either already in contract with or talking to, and legal stuff takes forever, right? So for Neo4j, of course, we've got Neo who's going to be going to market with us. More animation. Elasticsearch, distributed real-time search and analytics engine. Each instance is a single index, so this is the multi-tenant approach. Each instance is a single index from the shared cluster, and our partner for that is Elasticsearch, of course. If you're trying to take photographs, you have to be faster. MongoDB, simple and fast NoSQL database. Everybody knows Mongo, right? Each instance is a single database, again, multi-tenant, from the shared cluster, and our partner is MongoDB for that. We've got Memcache, high-performance memory object cache. Each instance is a separate Memcache process. And by the way, they have no good logo online. I don't know why, but they just don't. Could hire a designer. Cassandra, the highly distributed write-heavy KV or kind of column store. It's a weird thing. 5-dimensional or 6-dimensional key space. I don't know if you guys know that. Each instance is a Cassandra key space in the shared cluster, and our partner for that is DataStax. I love this quote when I was researching Cassandra a while back. This was a study done by the University of Toronto in 2012. In terms of scalability, there's a clear winner throughout our experiments. Cassandra achieves the highest throughput for the maximum number of nodes in all experiments. That's pretty ringing endorsement. We've also got MariaDB. Contrast could be better on that. MariaDB is a MySQL replacement. And when you pair that up with Galera, which is an HA proxy for MariaDB, you've got a fully HA MySQL replacement database. It's kind of the new hotness. So if you're already using MySQL and you don't know about Maria, you might want to research it. Each instance is a MariaDB database inside the shared cluster. So again, a multi-tenant solution there. And our partner for that is SkySQL. We've got, of course, Pivotal HD, the enterprise Hadoop distribution. Each instance in Pivotal HD is a cluster of dedicated VMs, kind of crazy. So PhD is the one who actually has a pool of hot VMs ready to go. When you request an instance, it grabs a couple of those through its own BOSH that it deploys. So BOSH and BOSH and BOSH inception. And hands you those. So that makes a lot of sense for PhD, right? You need a lot of performance, and cost is not so much the issue in terms of data center cost. And then what else? Oh yeah, React CS, S3 compatible Blobstore. Again, this is a multi-tenant solution where each instance handed out to the application developer is a single bucket in that shared React CS cluster. And our go-to-market partner for that is going to be Basho. Huh? Yeah, nice little animation there, right? So anyways, you can see here that what we're trying to do is find the right partners and the right technologies to make this Pantheon, this kind of nicely distributed map of SQL and NoSQL, relational and non-relational data technologies. We want to make sure that when you're deploying your app to Cloud Foundry, you have everything there to choose from, right? That's the whole point, is to enable that kind of agility where you can just quickly it's like a candy store, you just get whatever you want. All right. And then I'm going to talk about some of the challenges we faced, because I'm overly honest. One big challenge that we face when we're looking at building all these data sets, excuse me, kind of loud, is that it's not our data, right? And it is data. So it's drastically important. It might not actually be. It might be just crappy data, but we have no idea. So we have to assume that everything that goes into our data services is the most important data in the world. So we end up prioritizing durability and reliability over performance, and sometimes over cost, right? It's always great to be high performant, and it's always great to try and achieve that at a low cost point, but it's much more important to make sure that your collection of Buffy episodes doesn't get lost, right? Also, when you've got an army of DBAs who are maintaining your data sets, your databases, it's easy for them to tune them for your exact workload. I mean, if you're Twitter, you know exactly what your workload looks like, and it's very different than other workloads. So it's very easy for you to tune your data sets, your databases, so that they're going to work performantly in that exact situation. We don't really have that luxury because we're building something that works for everybody. Now, luckily, the Cloud Foundry Services API has that concept of plans. A lot of people think of plans as a linear progression of just bigger and bigger and bigger, but that's not actually how you should think of them. They are a small set of options inside each data service. You can have a plan for a write-heavy workload or a read-heavy workload or something like that within the one service offering. So that's something that we plan on leveraging in the future as we get more feedback from the customers saying, hey, I've got this one kind of workload and it's just really not working the way that your thing is configured. By the way, this background image I love this. Does anybody recognize this? Raise your hand. Okay, this is a poster you can buy online that is a scale image of every drone in existence with metadata on there in the forms of skulls and crossbones and things like that to tell you if it's a friendly drone or not and what country it comes from. On the other side of that paper is a reflective sheet so you can hide from the drone. Yeah. What versus how? So little known fact, I used to be an engineer. I still code sometimes. It's very difficult as a PM on this project not to tell the engineers that they must use Docker, right? Not to say that kind of stuff, not to get down into the weeds. In Pivotal, especially labs, and that culture has been brought into all of Pivotal, has a very strict and healthy delineation between the what versus the how, right? So I, as the PM, get to say, well, I want these things done exactly, and I want them done in this order. And he gets to say, okay, well, we're going to use Go, or whatever we want to use. And also, this one's going to take 3 months. I don't care what you say, right? So the what versus the how. And when we're dealing with such a highly technical product, and this is not just for services, honestly, this is for all of Cloud Foundry, it's a little more challenging to make that work. So we have boxing matches. It's good. Part of that was that we did end up doing a Go rewrite for a lot of the brokers. Again, not so much for performance, because it's not so important that the brokers be high performant, but more for the ease of deployment and consistency across the rest of the Pivotal CF and a lot of the Cloud Foundry products. We're finding that Ruby is great for prototyping, and Ruby is great for a lot of less performant aspects. It's certainly wonderful for our console and things like that. But in terms of cloud-level performance, especially when it's going to be deployed on-prem and we have very little idea of how much scale it's going to have to undergo, and we're not going to be there to babysit, something like Go is it's hugely helpful for us. It's something we can really gain a lot by leveraging that. The infrastructure feedback loop is slow. So this was really about when we were doing our testing and development feedback against AWS. How many people here have worked directly with the AWS API? All right. How many people here are happy with its performance when provisioning instances? I used to be the director of engineering for EngineYard. When I was over there, I worked there for, I don't know, like maybe 2 years or something like that. Towards the end of my tenure, I'm not joking, an instance came back under our account. Before then, it had been deleted before I ever got there. I don't know. We looked into, we call it AWS. We're like, what is this? We have an instance that we don't recognize. And they looked into the history, and they're like, oh, well, you deleted that instance, but the delete didn't work, so it came back. Two years ago. Right, yeah, exactly. Durability, that's good. So anyways, this has been mitigated mostly by Bosch Lite. Bosch Lite has been a godsend for the developers. So Bosch Lite, if you don't know, is basically a Vagrant VM that's running all of the all of the Cloud Foundry components in containers. I believe Warden containers, right? So that's really helped out with the feedback loop. We're building, in London alone, we are building 7 different data products, and we have 4 pairs. So I'm sure you can imagine that maintaining 7 tracks amongst 4 pairs is a challenge. To that end, we are hiring in London, not just devs, but PMs as well, because I'm also a bottleneck. But a lot of it is about finding commonalities, especially in the broker code and in the way we deploy these services and those patterns that were talked about earlier. If we can find those commonalities, we end up just stamping them out, cookie cuttering them, and it works really well. And of course, also partnering with those partners like DataStax who really understand the underlying data technology so they can advise us and help us with producing something that's turnkey and will keep running.
Something else that's also key is that with so many products, you have to automate things. There's not enough hours in the day to do it all. So we rely heavily on a pipeline. We make a change, and it just goes through, and eventually we get a big product out the other end.
Yeah.
So it's key.
Speaking of that pipeline and products out the other end, my history is in web development. So the very concept of having to ship a release it just rubbed me the wrong way. But this is the reality of on-premise solutions. So we do have shrink-wrap schedules. Now, Pivotal is a very agile organization, so it's not nearly as bad as you might imagine. It's simply that every so often we say, well, here's the features we've got. Let's wrap them up and stamp a version number on it, right? That being said, we still have to worry about migration paths for users, right? We can't make major changes without thinking, OK, well, what's going to happen if the user tries to get from point A to point C, right? So there's some challenges in there. So it's a challenging problem that we face, but it's very important to us. We believe very firmly that services are the key for the success of Pivotal CF. Especially with the latest containerization products, the public perception is that platforms are becoming almost a commodity. I have a feeling, especially with the big Docker movement, that soon people will realize that simply having a container is not nearly the same as having a platform. But the most important aspect of a platform is the data services that you can provide underneath. Again, it's about enabling agility so that your developers, when they want to try something out, all they have to do is click on it, and now they're good to go. That kind of thing has never existed before. If it happened when I was a developer, I would have had a much different career. But this is the most important thing to us, so it's something that we're putting so much thought and so much energy into. And again, I wanted to make sure this happened quick so you guys could get your break. I don't know if we have time for questions. Anyone yell it out? We also wanted to thank Cloud Credo, who's in London, and they've been helping us out with the service development. Some Cassandra experts on their team, certainly Bosch experts, great guys. So 1, 2, 3, any questions? Raise your hands. One question.
For enterprises that are interested in on-prem, are these solutions, these services available for an on-prem?
Yes, all these services are geared towards on-prem deployments using PCF. Other questions?
Asynchronous API?
That's,
Are you any plans to do an asynchronous create a service?
we're not in charge of the API, we're in charge of the services. That's his fault. All right, I'm going to call it. If you guys want to ask us any questions, you can find us outside. Thank you.
Thank you.